Hello, everybody. Hope everybody's having a good day today. Our learning target for the day is we want to be able to solve equations that have variables on both sides. So a question that might look like this one right here. So 6x minus 4 equals 7x. I have an x on this side and an x on the other side. What do I do? How do I figure out what that x is? Today, I do want to show you that I'm going to try and use something else to help you guys kind of organize. Um, we just talked about our goal. Then we're going to do some reviewing. Then we're going to do 5 steps for solving. Then we're going to do more examples. And lastly, we're going to end with a word problem. I know some of you are skipping some of the steps in these videos because you don't need that. Like some of you are like, gosh, I really can combine like terms. I don't need a review of that. That's fine. So to help you out with that, I'm going to try and remember to highlight as I go. So we're going to start with combining like terms. So that one's going to be green. And then when we do the distributive property, we'll do that. That way, when you guys fast forward across the bottom, you can kind of see where we are based on that. I hope that helps. So our first example, all combining like terms. How do I combine like terms? Well, what we really need to think about is the way that we're saying it. Terms that are alike. So if I look at this, I use subtraction and addition symbols to separate terms. So here I have 4 terms, 1, 2, 3, 4, and I'm going to combine the ones that are similar. The ones that have x's are similar. So 2x minus 4x, that's negative 2x. Negative 4 plus 2, those are the two that are similar because they don't have any x's. So that gets me negative 2. This is simplified. There's nothing I can do to make this simpler. Here's another example of combining like terms. What terms are the same? Well, here I have a 3 and a 5 and an x. Well, there's only one x, so I know I'm not going to combine like terms with that with any of them, but I am going to combine the 3 and 5. So this becomes x plus 2, because negative 3 plus 5 is positive 2. Last example of combining like terms, 9 plus x plus 2 minus 3x. If I look at my x's, I have x minus 3x. What we need to remember is there's secretly a 1 on that x. So 1x minus 3x gets me negative 2x. Then I have 9 and 2, which I can add together because neither of them have an x on them. 9 plus 2 is 11, so plus 11. So these are simplified forms because I combined like terms. Moving on to our distributive property. Our distributive property is where we have to distribute the value that's outside the parentheses to the two terms inside the parentheses. So for example, here I have 1/2 times 4x times 8. A lot of times you guys will kind of draw the little rainbows across the top. So this becomes 2x plus 4. 1/2 times 4 is 2. 1/2 times 8 is 4. Same thing here. What I want you to stress here is this negative. Whenever I have something like this, the negative actually has to get distributed to both of the terms. So negative 3 times 2 is negative 6x, because there's that x there, so we have to come down with them. Then I have negative 3 times negative 4. Remember, if I have two negatives, that makes a positive, and I get 12. Again, do not be afraid to throw that calculator on there and be like, wait, is that right? Did I do that when I multiply by two negatives? If I have negative 3 times negative 4, yeah, that is positive 12, so I did that right. Good. Negative 9 times x is negative 9x. Negative 9 times positive 2 is negative 18, and I'm done. This negative 9x might be a hard one to get, but it actually goes back to what we did here. Remember where we put the 1 on there? If we ever have an x by itself, there's secretly that 1 hidden there. Negative 9 times 1 is negative 9. All right, now we're going to do our 5 steps for solving. So we're finished with our distributive property. If you guys have questions on the distributive property, anything like that, make sure you're stopping me in class and asking. I really appreciate how everybody has been working hard in class. All right, 5 steps for solving. So I have them listed here for you. I'm going to do this example, which is one of the simpler ones. Then we're going to come down here and we're going to do some examples together. And then I'm going to come back up here and do this tougher example. And not even tougher. There's just more to it. It's not tougher. So step one, use the distributive property to remove any grouping symbols. So grouping symbols would be parentheses. Do I have any parentheses in this one? No. Here I had parentheses, so I had to do the distributive property. No parentheses. I don't have to do anything for that. So I'm going to move down here. I didn't have to do anything for that step. That's kind of nice. So here is 6x minus 4 equals 7x. I just rewrote it again. We're moving down to the next step. Simplify the expression on each side of the equation. Each side just means this side of the equal sign and this side of the equal sign. Are there any terms that I can combine on this side? Are there any terms that I can combine on this side? What some students will say is like, well, I can combine the 6x and the 7x, but that's not combining like terms. Notice our combining like terms example, there's no equal sign. We didn't combine across an equal sign. We can't do that. Think of this as a divider. What's over here has to stay over here. What's over there has to stay over there in step 2. Can't not combine like terms here. So this step is done. So now I'm going to rewrite this one again. 6x minus 4 equals 7x. Now it says collect the variable terms, the ones with x's, on one side of the equation and the constant terms on the other side. Constant terms are the ones without x's, like -4. So I need to take either my 6x and move it over here, or my 7x, and I'm going to move it over there. I am going to take my 6x's away, and I'm going to move them to the other side. And I'm going to do that by subtracting 6x from both sides. So I'm adding this in here, minus 6x. I'm subtracting 6x from both sides of the equation. 1 second here so we can look at that a little better. So I wrote 6x here and I wrote 6x here. So now what is my equation? 6x minus 6x, that goes away and I just leave -4 equals 7x minus 6x. That's just a single x, so 1x, or even just x. Now I have -4 equals x, and I'm done. My x is by itself. I know the solution is -4. If I wanted to double check my answer, I would bring it up here, and I would write a -4 in for here and a -4 in for here, and both sides of the equal sign should be true. So that was the isolating the variable. And then checking my solution is taking it back up to make sure. 6 times -4 minus 4 equals 7 times -4. 6 times -4 is -24. Minus this 4 that just comes down equals 7 times -4, which is -28. -24 minus 4 is -28, which equals -28. So this is true. Because this is true, I know this is the correct solution. We did it. All right, let's take a look at a couple more examples down here. Well, actually, we're going to do these two examples, then we're going to come up and do this tough example together. So my step 1 is always look to see if I can do the distributive property. With this example, I can't. Now I'm going to look to see, can I simplify the expression on each side? Can I combine like terms anywhere? Well, here I have 3w, here I have 4w, and they're both on the same side of the equal sign, equals here. So these two are on this side, both on the left side of the equal, so I can combine like terms. So I'm going to get 3w plus 4w, that is 7w, minus 2 equals 12. Now I'm going to take this and I'm going to add 2 to both sides, because step 3 says collect variable terms on one side and constant terms on the other side, so -2 and 12. So how do I move this -2 over? I add 2. So now I have 7w equals 14. Now I'm going to divide both sides by 7. which gets me w equals 2. Notice I'm doing this problem, and this is exactly like what we had in 1.2. So I'm not writing out the plus 2 on both sides. I'm not going to write divide by 7. You need to do that on your homework assignments, wherever you're taking notes. When you take the test, you'll need to do that. But as I'm going through this, in the interest of time, I'm not going to be doing that. Make sure you have that on there. Here's another example. Now, if I go through my steps, use the distributive property to remove any grouping symbols. Well, so that means I'm going to have to distribute this 3 through. So 3 times b is 3b. 3 times negative 2 is negative 6. Equals 7b minus 4. Now I'm on to step 3 because there's nothing I can do to simplify. It says collect variable terms on one side and constant terms on the other side. It doesn't matter which side goes to which. I can move my 7b's over here, or I can move my 3b's over there. It does not matter in any way, shape, or form. So I'm going to subtract 7b from both sides. 3b minus 7b is negative 4b minus 6 equals 7b minus 7b is no more b's, so they're gone. It canceled out. I'm left with negative 4 on this side. So I subtracted 7b from both sides. Now I'm going to add 6 to both sides so I can move this one over here. Negative 4b minus 6 plus 6, they cancel each other out, so that's gone. When I add 6 to the other side, I get 2. So now I have negative 4b equals 2. My next step is I'm going to divide both sides by negative 4. So b equals 2 divided by negative 4, which can be simplified to be negative 1/2. And that's my solution, is 1/2, negative 1/2. This is the value that I could plug in up here to get a true statement. I'm going to do this tough example with you. Then I'm going to have you guys do these 2 examples, and I'll just throw the answers up there, okay? So we're still on our 5 steps for solving. Use the distributive property to remove any of the grouping symbols. I have 2 sets of parentheses with a number on the outside that tells me there's 2 places where I'm going to use my distributive property. 2 times 3 is 6x. 2 times negative 4 is negative 8. And I'm just going to bring down the rest of it. Plus 3 equals 1/2 times 4, that's 2x. 1/2 times negative 6 is negative 3. And I'm just going to bring down the rest. It's really important to me that you guys recognize that I'm doing a lot of this math in my head. I understand that not all of us can do that. Not all of us can multiply 1/2 times 4, and that's okay. Use that calculator to make sure that we're getting correct answers, because I'd much rather you got the calculator out and checked it than got the wrong answer at the end, okay? Step 2 is we're going to simplify the expression on each side. So I'm going to combine like terms with just this side. Then I'm going to combine like terms with just this side. That's it. I'm not going to take this 2x and put it with this 6x, or this 2x and put it with that 6x. This equal sign is a divider until I get to step 3, okay? 6x minus 8 plus 3. Well, 8 and 3 don't have an x on it, so I'm not going to be able to combine like terms with those, so with the x. But I can combine with these 2 together because neither of them have an x. So I have 6x minus 5, because negative 8 plus 3 is negative 5. Then I have 2x, negative 3, and 2x. I'm going to combine like terms with my 2x's to get 4x minus 3. Now I've done step 1 and step 2. Distributive property is done, and combining like terms is done. Now in step 3 is where I can start getting them together on one side. So I'm going to get my 2 variables on the left and then my 2 constants on the right. So first thing I'm going to do is I'm going to subtract 4x from both sides. If I wanted to, I could subtract 6x from both sides, and I'd end up with the right answer at the end anyway. Subtracting 4x from both sides gets me 2x minus 5 equals negative 3. So remember what I did there was subtracting 4x. So 4x minus 4x, they cancel out. 6x minus 4x gets me 2x. When I subtract 4x, it has nothing to do with the negative 5, and it has nothing to do with the negative 3, so they just come down. Now I'm going to add 5 to both sides to get 2x equals 2 plus 5. So negative 5 plus 5 cancels out, they go away. Negative 3 plus negative 5 gives me a positive 2. So you can kind of see that two sides of the equal sign. Do that to this one too. See if they stayed the same. All these values came from up here. Look at this one. Look at this one. This is where we moved, right? Plus 5 to both sides. Now isolate the variable. That means I want to get just an x on this side. This is just like we did in 1.1. So I'm going to divide both sides by 2. So x equals 2 divided by 2, which is 1. So my answer is x equals 1. And I can take this up to check to make sure. Is that going to work? If I think about it, 1 times 3 is 3, minus 4 is negative 1, times 2 is negative 2, plus 3 is 1. Then on this side, if I put in 1 here, 4 times 1 is 4, minus 2 is negative 2, negative 2 times 1/2 is negative 1, 1 times 2 is 2, negative 1 plus 2 is also 1. So this side equals 1 and that side equals 1. I know that was fast, so let's take a look at it down here. Here's my main problem. And I'm substituting out the x for a 1. Three times 1 is 3, minus 4 is negative 1, times 2 gets me negative 2, plus 3 gets me 1. So this whole side became 1. Then on this side, 4 times 1 is 4, minus 6 is negative 2, times 1/2 is negative 1, plus 2 is 1. So this side simplified to be 1, this side simplified to be 1. So I know I did it correctly. I know my answer is x equals 1. So this is what I'd put into the computer on Clever, is x equals 1. Okay, more examples. So I'm going to have you guys pause, do these on your own, and then you'll come back, and in about 5 seconds, I'll show you the answer. Make sure you pause now. Okay, I'm going to show you the answer in 5, 4, 3, 2, 1. You should get y equals 1 and x equals 17. Those should be the two answers. Here are the steps for solving if you need to pause and look at those. And we are going to move on to our modeling with mathematics. So the last problem in your homework, number 17, is a word problem. So I wanted to do a word problem example with you quick. If you look at it, we're talking about going to a movie and stuff, but I don't really need to worry about that because if I look at it, it gives me the equation. So all we have to do is simplify this equation. We need to solve for r in this equation. So this time I have 1.5r plus 15 equals 2.25r. I don't need to do any distributive property. I don't need to simplify. I need to collect the variables. So I'm already on step 3. So I'm going to subtract 1.5r from both sides. 2.25 minus 1.5. Let's make sure we do that right. So I'm going to grab the calculator so I know for sure that I'm doing it right, especially when I'm dealing with decimals. 2.25 minus 1.5 equals 0.75. Okay, so 0.75 R, or 0.75 if you like. Now I'm going to divide both sides by 0.75. 15 divided by 0.75 gives me 20. Okay. So 20 equals R. Then I have to answer the question, right? So how many movies must you rent to spend the same amount at each movie? Oh, well, 20 movies is my answer. Okay, we are finished. You can move on to your homework. I believe in you. Let me know if you have questions. Proud of how hard you guys are working. Keep up the great work.